Hello everyone. Today I'm going to discuss about Java util concurrent package. So Java util concurrent package, we have so many classes and interfaces. So uh, I will go through all of the classes and interfaces initially, and I will go through each one in couple of videos in couple of next videos. So uh, it's include mainly focus on some of the useful utilities for the concurrent execution of a program. So the first one it's included is a executor interface. So executor interface that represent an object that execute provided task. So instead of creating new thread in our own program, we can call this executor interface a execute method to create a new thread. So that's an interface, and executor service is a complete solution for asynchronous processing. It manage an in-memory queue for executing threads. So you can have a executor service with a fixed thread pool, or and just one single thread pool that you can create based on executor service. So usually in most of the multi-thread programming, executor service is the best choice, and people are mostly using this one. So for interviews it's very important. So there are two types of executors: new single thread executor, or a multi-thread executor. So new single thread executor create only one instance. Then besides that, we have a scheduled executor service. So scheduled executor service is a similar interface to executor service, but it can perform tasks periodically. You can schedule a time for that one. And we have a future. Future is used to represent the result of an asynchronous operation. So if we are using an executor service, the result we are getting is future. So future of particular result type. So uh, we can use that to get a result from the execution. So in coming videos we will see how we can use future in our program. So that's all. Not that so. Besides that, we have other things also. We have countdown latch is there. So countdown latch is introduced in JDK 5. It's a utility class which blocks a set of threads until some operation completes. It will block a set of threads, not a particular thread. So until some operation is complete, that's a thing countdown latch will do. CyclicBarrier, also another one that also usually in most of the multi-thread programming program we will use. So we need to know that also. CyclicBarrier is almost same to CountDownLatch. So we will see what is the difference between that two. So basically right now we need only to have a idea about what is CountDownLatch, what is CyclicBarrier. Then we have Semaphore. Most of the people I guess will know about the Semaphore is used for blocking thread level access to some part of the physical or logical resource. uh, so it's a permits based things we will see in next couple of videos. That also, if permit is not available, uh, it will try to occur that. So if it is not occur, it will it will be in queue or something. So we will see what is that. The other one is ThreadFactory. it acts as a thread pool. So executor service, using executor service we can have a thread pool. So ThreadFactory is also there. So ThreadFactory is an interface. So if we implement ThreadFactory, you can create a pool of threads, I guess. Then BlockingQueue, most common integration pattern in producer consumer pattern. The Java util concurrent package comes with the data structure BlockingQueue, which can be very useful in the asynchronous scenarios. More details we will discuss later. So actually, uh, in BlockingQueue, the scenario is like uh, it will wait until a new entry is coming to the queue actually. So the thread will wait until getting a new element in queue. So another one is DelayQueue is an infinite size blocking queue of elements where an element can only be pulled if it is expiration time. So we need to discuss more about that. So another one is logs. So logs also important. So log is utility for blocking other thread from accessing a certain segment of code. And the last one is phaser, is a more flexible solution than CyclicBarrier and CountDownLatch, used to act as a reusable barrier on which dynamic number of threads need to wait before continuing execution. So overall, if I am going through this one, you need to know executor service, you need to know future, you need to know CyclicBarrier, you need to know Semaphore, and blocking queue is important. Delay queue is not that much important, but logs is important. So uh, in coming videos we will discuss about all of this one with examples actually. So we will start with executor and then executor service, scheduled executor service, future, countdown, latch, cyclic barrier, semaphore, thread factory, blocking queue, delay queue, logs, and phaser. So tune for my next video. I will start with the executor interface there. Thank you for watching this video. So actually I'm not done anything yeah, in current IntelliJ IDEA environment. So I guess I will go to executor service right now because we need to show something, right? So what I'm going to do is I will create a package here, so I can make everything into a particular package right now. So here I am going to create a executor testing. So how I will implement that executor testing, I need to go through that. So based on some of the online documents, it's saying like concurrent API in Java provide a feature known as executor that initiates and controls the execution of thread. So before that executor, we are using thread class itself, thread dot start. So instead of that we can use the executor interface. So where this executor interface situated in Java 8 or something, yeah, Java util concurrent package. So there is an interface called executor, and um, I guess yeah, in that one, if we are going deep on that, this executor already implemented an executor service and scheduled executor service. In implementing classes, so executor service and scheduled executor service also interfaces. They are also, yeah, implementing that. Implementing classes include abstract executor service, fork, join, pull, scheduled thread pool executor, thread pool executor. Maybe we in future we will go through that. Execute this function, execute the given command at some time in the future. So we will go to the code right now. So we all know that executor is an interface. So I can have a so I don't know where I executed testing, where I put that. Okay, in the wrong package. So I put in here. Okay, I moved to my package. So what I am going to do is I am creating a class called Executor, not Executor Service. I am Executor Imber. It is a class that implements our executor. Oh, that's not the one. So we are in util dot concurrent. Okay, we have some problem here. Not a problem. Import class. So it will executor Java util concurrent, and it will ask for implement this method. So we are keeping that here. So what I'm going to do is actually I need to have a method here. I mean, I need to create a thread here. So I'm going to create a thread by implementing runnable interface, implements runnable. Okay, it will ask for me to the run method. So here system dot okay. So what I'm going to do is I need to create a new thread here. And I'm going to start. Actually, I need to pass the thread here, right? So here, here I have everything. I can start from here. I can start from here, just calling the executor. So I will do the, I will call the execute to execute my, to start my thread. So for each time it will start a new thread. So I will go to executor testing here. In executor testing, I will have a public static void main. Okay, then I will make something like executor import object. Yeah, probably executor will be okay. Executor new executor import. Okay. Okay, I'm using that one here. Okay, so right now we are okay, and I'm just calling this one executor.execute. Then I will call new thread. New thread, our own method. Executor testing. Okay, so what what I am doing here, I have new thread, so I am just calling that new thread to execute that using the executor framework. So let's see whether it's working right now. I'm going to run right now. Okay, so it's called by execute, so there is no connection between these two actually. So where I am mentioning this one, so I have a new thread and it accepting a command. I mean, this is a new thread, so I am passing this new thread to here, and it's calling the start on that. So executor is doing work for us, we don't need to start. So it's an overhead, yeah, overhead about the thread, but it's useful. So if we need to create new thread each time and to start, we can do that. Else you need to create the new thread manually, right? So executor right now care about this one. That's it.